Hello, so today we are going to do this problem called longest consecutive sequence. So given an array, an unsorted array, we want to return the length of the longest consecutive element sequence. So what this means here, especially consecutive, is that it's each element, the difference between each element and the next one is 1. So basically 1, 2, 3, 4, 5, this is a consecutive sequence. 2, 4 is not, because the difference is 2, so that's the idea here. Now if you take a look at this example, it doesn't matter the order, by the way. So here 1, 2, then 3, then 4. So this may be confusing a little bit, but just remember the order doesn't matter. We just need a consecutive sequence. Here it's 0, 1, 2, 3, 4, 5, 6, 7, 8. So we have basically from 0 to 8, and they are shuffled, so we end up with 9 consecutive sequence. Okay, that's the longest one. So that's the idea. The thing though is that we are asked to do this in oven time, right? So of course we can definitely just sort, right, and just go through it, and see if we find, as soon as we find an element and its next that are not consecutive, we record the count and check if it's the max so far, and then we start a new streak of consecutive sequences. So we can do that, but that's using sorting, so it's n log n, right? So we need to think about a better solution. Okay, so let's see how we can solve this. So the main idea here is to use either a map or a set, but essentially we need to keep track of the elements that exist in the array, right? So for that we can use either a set or a map, a hash map, that is. And then we can just go through the array, right? And we need, what do we need to do? We need to find the maximum count, right? And so for each, we can either, so the first simplest solution is to go through the array, so to go through every number in the array and just find the string that starts from that element. So with that, what we can do is basically start from A, so start with maybe current equal to A, right? And each time check if the current plus 1 exists in the numbers, and with that we can use this set or map, right? As soon as we find that it doesn't exist, we are done with that element, we go to the next. So pretty simple there. So here we can do while current is in our set, let's call it exist set or something like that. Then what do? We increment current, right? So basically, let's say we are in an element 2 in the array, right? We want the longest contiguous sequence, so we are looking for 3. If 3 is in the array, then our longest consecutive sequence, our consecutive sequence so far is of length 2. Next, we try to find 4. If it is there, then it's 3. If not, then we just check if this is the max we have so far, right? So pretty much here we just increment count, and then we increment our count of the current sequence, right? And so here we need to initialize our count as well, okay? And then we need also to keep track of the max so far, so we call it max count, right? So we do max count here is equal to the max so far and the count. Okay. So, and then at the end we can return max count, right? But there is one thing actually. So let's say we have this sequence 5, but it's like in an array like this. Maybe we have 0, 9, 3, 2, 12, 4, 15, 5. So you get the idea, right? it doesn't make sense to start. So when we are traversing the array, we'll start from 3, and then we'll find 4, we'll find 5. Okay, so we'll say the length is 3. And then we'll go to 2, and we'll find 2, 3, 4, 5, so we'll say the length is 4. So it's always better to start from the number that doesn't have the previous element, that doesn't have the number -1 in the set. Right, because that means it's the start of a sequence, right? Starting from the middle or from an element after the first element in a sequence is useless, right? Because we will find a longer sequence by starting from the start of the sequence. So how do we detect the beginning of the sequence? So that's the optimization here that will be useful here. So to know that it's the start of a sequence, well, it's enough that the element -1 is not in the set of elements, right? If it's not there, then we know it's the beginning of a sequence. So we do if here a -1 not in exist, only then that we check to find the max count. Okay. And this is effectively actually all of them, because we won't have start of, if there is a sequence, we won't have at most this entire loop will run n times. Okay. Okay, so that's pretty much it. But the main optimization idea here is this one. With this, we reduce the number of times this runs by just the number of consecutive sequences we have. Yeah. And so yeah, let's run this and make sure it passes test cases. Okay, so I have the code here, the same code that we just saw in the overview. So pretty much exists, there is a set of the numbers, so we can easily check if the number exists or not. We go through the numbers. If the number, if it's the beginning of a sequence, we check by if the previous number doesn't exist in the array, then we start counting this sequence. And so while current didn't exist, we increment current, we increment the count of our sequence so far, and then at the end we check if it's the max, and then at the end we return the max count. So pretty straightforward there. Let's run it, make sure it passes. Okay, let's submit. Okay, so it passes test cases. Yeah, so that's pretty much it, I think, for this problem. Thanks for watching, and see you on the next one. Bye.